Welcome to the presentation for our groundbreaking project, Llama-Mada to our nerd professor LLM. Using Tiny Llama 2, today we'll discover how this AI model transforms technological education, making complex technology concepts accessible and captivating for everyone. In this digital age, explaining technology in simple terms is essential. Our project utilizes Tiny Llama 2 to emulate diverse communicative styles, ranging from a wizard discussing muggles technology to a Star Trek enthusiasm to an AI expert. Our goals were ambitious to customize an AI model that explains and engages using narrative that resonate with people's experiences and interests, inspired by the potential to make learning seamless and fun. We developed a model that adopts the personas of a wizard, a Star Trek enthusiast, and AI professor. Each persona is designed to approach technology education from an unique angles, making complex concepts more accessible and relatable. This method aims to cater to different learning styles and preferences, enhancing educational outcomes.
The execution involves several key phases. First, leveraging ChatGPT capabilities, we generate a tailored dataset that forms the basis for training our Tiny Llama 2 model. This involves complex Python scripting to automate data generation through the OpenAI API, using DaVinci models focusing on creating diverse and role-specific content, using meticulous prompt engineering to obtain a specific output which was later manipulated to fit our needs. We ended up with 800 diversified dialogues, 200 inspired by Wizard, 200 setting the Star Trek universe, and 400 about artificial intelligence. Each dialogue is crafted to reflect the assigned role and communicate effectively. With meticulous attention to the dataset diversity and depth, we process the information to align perfectly with our model's learning needs, creating and formatting a script that translates the output from OpenAI into a particular format of the model used. We create two different formats for different models: chat and text generation, from which we use the chat version. Once we have the dataset ready, the fine-tuning part is ready to start. Using Google Colab's powerful computing resources, we fine-tuned the model through multiple iterations, optimizing parameters like learning rates and epochs for best performance.
The training was conducted in Google Colab, where critical elements such as the learning rate and epochs were adjusted. The model used transformers and Hugging Faces libraries, loading a particular model of Tiny Llama 2, the chat version, suited to fit on the free tier of the Google Colab. Initially, training with just one epoch and 250 steps yielded poor results. We had to purchase more computing time on Google Colab to train with infinitive steps over 3 epochs, achieving a substantially good result with training loss of 46.87%. We adjusted the lower weights to ensure that we didn't lose the previous training, focused only on learning the new data from our datasets. We used Google Colab Pro with 800 GPU, and it took around 1 hour. The journey wasn't without challenges. Balancing computational cost with the need for extensive training required clever strategies and optimizations. Yet, the process was incredibly rewarding. Collaborating as a team, solving problems, and seeing our creation succeed brought us immense joy and satisfaction. With the ability to perform intense training, we achieved a 2 gigabytes model that responds instantaneously. It is now possible to use that same model and reload it again and start making inferences without the need to train again. Results and demonstration. Watch now the model answer the question, what is a transformer, in 3 different styles, one for each role, and each response is not only accurate but also tailored to the narrative context of each role. The first one, the role as a wizard to answer in Transformers, it's picture a magical artifact that weaves spells and incantations into the fabric of reality itself, transforming the very essence of existence with each utterance and casting a spell of transcendence that defies the boundaries of time and space. Like this, we can see also how the Star Trek answer what is a transformer, a type of neural network architecture commonly used in natural language processing tasks, like the ship's universal translator, allowing for communication with alien species. As you can notice, it is already tailoring the answer for Star Trek fans. The last one, as a professor explaining difficult topics in a simple way, the answer is a type of neural network architecture introduced in the Transformer paper by Waswani for the sequence to sequence task, like efficiently processing long sequence in parallel response. And finally, this is the answer from our base model. As you can see, it is a larger and more detailed answer. And how this is how we can compare like all three roles and how they can achieve to explain a difficult topic in a more simple way with some tailoring or customization of other elements like the references for Star Trek and Harry Potter universes.
This approach not only enhances technological understanding but also opens new beyond the classroom. Imagine it used in customer support, where it can provide technological help, or in content creation, enriching media with engaging educational narratives. Looking ahead, we plan to expand the model capabilities to include more languages and cultural context, further enhancing its capability and reach. We also aim to explore more advanced AI training techniques to refine its adaptability and performance. In conclusion, Llama 2 has exceeded our expectations, paving the way for future research and developments. We invite you to join us on this journey, exploring new frontiers of artificial intelligence. Thank you for watching us. Don't forget to follow us for more updates and innovative developments. Until next time, thank you.